Hello and welcome. My name is Taras Dekun and I'm sales engineer at MEA Incorporated. And today we'll be talking about delayed coker high performance actuation systems from MEA Incorporated. So, agenda for today presentation. We would like to introduce ourselves, talk about our background in the delayed coker units, talk about the recent MEA developments, and how these recent developments apply to a delayed coker unit. After, we would like to receive all your questions, and of course, I would love to answer it for you. So, just to start up with MEA history. So we've been in the business for over 70 years now. We started a small company in suburbs of Chicago land area and developed and provided our actuator system to the steel mills within the area. Over time, we developed a special actuation systems for FCCU unit. Over time, we also developed damper drive actuators for nuclear power plants. Participated in delayed coker unit switch valve actuation packages. And in recent years, we keep working with a variety of customers in FCCU delayed coker units, and additionally with the development of our self-contained electro-hydraulic actuator system in 2014. We've been starting participating in many other different markets all over the world. However, throughout our history, we developed electro-hydraulic actuators for vast variety of application. Most of these applications are supercritical applications for the control services, and we continue to do so. MEA product categories can be divided in four main categories, which include MEA Hawk, which is self-contained electro-hydraulic for modulation services, which we're going to be discussing today majorly. Also, we can talk about MEA Raven, which is self-contained electro-hydraulic actuator for on-off or isolation services. Additionally, MEA produce two types of hydraulic power control units, which is MEA Eagle, which covers the hydraulic the services for high critical modulation services. And additionally, we develop our hydraulic power control unit for on-off services, which is called MEA Phoenix. So, as you can understand, MEA been developing and building these hydraulic power control units and electro-hydraulic actuating technology for many years. And this development basically made us specialize and be an expert in these categories. So going back to MEA history in DCU application, one of the MEA over its history participated in very vast variety of application within DCU. However, our most and major influence was done within the actuation technology for Wedgeplug style coker switch valves. So MEA is actually the first company who developed the full automated package for Wedgeplug style coker switch valve in 1996. This was a collaboration with the Flowserve at that point in time, which developed the Wilson Schneider coker switch valve. So this collaboration included the actual switch valve and attached to it fully hydraulic actuator system. So basically, this actuator system came with a PLC with a kind of hydraulic manifold, which then connected to a hydraulic actuator, which developed the force and operation of lift and turn. I would say it would unseat and seat the valve and then hydraulically operate the valve in a rotational motion. So this collaboration actually created a great package, which is still in operation in numerous of the refineries all around the globe, and still being produced by MEA and fully supported. So basically, over the years, we developed and produced about 50 different types of actuation control system in the coker units, especially for this application. and it was involved about 20 coker units globally. So coming up to the MEA recent development over years, so with our expertise in electro-hydraulic actuator systems and in vast variety of critical services, we received a lot of good feedback from the customer, and we asked them basically what was the pain points about the current electro-hydraulic actuator systems. And always, as we would be explained, a lot of customers really didn't like that there was a lot of large reservoir of oil required. When you had to basically go ahead and change this oil, it would sometimes leak, it would get spilled, it would have to require to be sampled. Um, and additionally, a lot of customer complained about regular maintenance, which require filter changes. And additionally, these systems are quite complex in general. And that was another, basically a feedback from the customer, as these systems do require a lot of components. So there is a large reservoir of oil, hydraulic motor pump assembly, some type of accumulator which stores the hydraulic pressure. Then there is some type of valve, solenoid, the servo valve, which directs the flow into the cylinder. Then all this system is getting operated as with a controller. And as the time goes, these complex systems get more and more complex, which require more cost for installation, more maintenance, and more cost of the ownership. So MEA kind of put all of these thoughts together and thought about how we can make it more simpler, so how we can make this less um, less costly, less maintenance, better, but keep the same reliability and performance of the system. As we all understand, electrohydraulics work best for all the critical services, as we can develop a lot of thrust, a lot of torque, high precision performance, uh, and accuracy of these actuators give the perfect and the required performance and the reliability that requires for especially units like delayed coker unit. So we kind of over time we developed this few things that we thought, okay, so what is the ideal state of electrohydraulic actuator? So for ideal state at this point we understood, well, you don't need the reservoir because people tired of checking the oil samples, changing oil, dealing with oil, and we basically need to eliminate that. Additionally, people are tired of, and customers were tired of filters and additional maintenance associated with these units. So we basically said, okay, how we can eliminate the filters. And additionally, we're talking about how can we make this system very small and compact, additionally not running all these hydraulic lines across the whole plant. And MEA engineers basically sat down, thought about it, and developed this electrohydraulic actuator system, which basically changed the whole mentality of actual electrohydraulic. So in the back day, which we do still this day, and numerous of companies still do the same thing, including MEA, we take hydraulic fluid from some type of reservoir, we pump it through the hydraulic motor pump assembly, and then we charge it the accumulator, which stores the hydraulic pressure, basically energy, and send this hydraulic pressure through the manifold, which then directs the flow into one side or the other of the cylinder. So usually these motor pump assembly constantly running because they have to recharge the accumulator, especially this is more critical for control services. However, it's constantly running, keeps all this hydraulic pressure it's available all the time, works well, and of course it's been used in many applications all over the world. But at this point in time, MEA thought about it. So how can we combine all of what this thing can do with the ideal state of the actuator system? And basically this resulted in development of this MEA Hawk, which is basically this hydraulic power control source, this red box over here, which I'm going to explain how it works in a second. So the whole idea of how we developed this was this unit works and operates constantly charging the accumulator, and then this pressure is used to operate the actuator. However, this unit is actually builds hydraulic pressure on demand. And so understand you, however, this building hydraulic pressure on demand does not have a trade-off in performance. So how we kind of did this was that we use a high-performance servo motor, which can operate back and forth constantly, non-stop, 100% duty cycles, 365 days a week. A year. And then with this type of mentality, we were able to eliminate about 80% of the components from the traditional electro-hydraulic actuator system and combining into this one little actuator. So this little actuator contains all the control modules and the motor pump assemblies, and of course you still have a cylinder, but it's only getting connected with motor and power signals, and of course you still get a controller. So how it works? So, and what is actual this module looks like? So this is, you can see the breakdown of the actual actuator. So we utilize this high performance servo motor, which can operate back and forth all day long, and it can build up pressure within 80 milliseconds or less in one way or direction, even with the changing of directions. So this servo motor is actually coupled to the bidirectional gear pump, and all it does is actually just pumping hydraulic fluid from one side of the cylinder and into the other. And this cylinder is equal displacement hydraulic cylinder. So everything just happens instantly, and the hydraulic fluid just getting pumped one side to the other, one side and the other. So it doesn't require any additional components, reservoir, filters, or any other associated devices. So especially after each repositioning, these solenoid valves just lock in place and keep the cylinder securely in one place. So development of this hydraulic power module enable us to attach it to basically any type of hydraulic actuator or linear rotary damper drive. And with this type of technology, we're able to increase the participation of MEA all over the world in so many different applications within refinery, liquid and gas pipelines, mining and metals, power generation, and waste and water treatment facilities. As you can see in these pictures, these units come in all different shapes and sizes and in all different type of applications. So with development of MEA Hawk, one of our customers approached us in basically about 3 years ago and said, so how can we apply this technology within a delayed coker unit? And we are able to actually apply the same technology within a delayed coker unit, which resulted in development of an actuator which we called MEA Hawk Switch, which is now can be used and is actually used right now for Wedgeplug coker style switch valve and Wedgeplug style isolation valves. So what we did, as you remember, in 1996, we developed this large hydraulic power unit, which had these large accumulators and all large reservoirs and connected to hydraulic actuator. We took the same technology and the same kind of electro-hydraulic idea and combine it in using our hydraulic power source. Basically, this hydraulic power source is responsible for seating and unseating the valve, and then there is additional electric servo motor operates the rotational function of the valve. And everything is getting operated by our control enclosure, which has an HMI screen and just a servo drive, and then fully capable to accept all sorts of signals and all sorts of signals and give out all sorts of signals back to DCS and SIS. So how it works? So just to fully understand the whole setup, I just kind of wanted to show you a schematic. So just to kind of show you the outline, so there is a hydraulic cylinder is attached to a Wedgeplug style switch valve, which is responsible for seating and unseating of the valve. and then there is a gear sitting on a valve stem, and then there is a servo motor gears assembly, which is being operating this gear here. There is a position feedback at the top of this actuator, and it feeds the signal back to the control enclosure. This is a high resolution position feedback to be able to monitor the gap of the valve of seating and unseating. Additionally, a servo motor comes with a high resolution encoder, which during the rotational motion we able to completely see each point of the rotation. Additionally, there is a hydraulic power source, which basically eliminates by this over here, which is communicated also to the control enclosure. So just to go through the sequence of the operation and explain how everything works, we receive a signal from SIS, which is a permissive signal, and then we tell from DCS, please actually go to drum A or B or whatever. So how it works is basically hydraulic cylinder. We unlock these solenoid valves, both of them. We open them up, and then we starting our motor pump assembly, and we just basically take hydraulic fluid from one side of the cylinder and put it to the other side of the cylinder, basically making the valve to unseat. Additionally, each side of these seating and unseating values are set with a small tiny accumulators and a pressure transmitters. So these pressure transmitters are actually used for seating and unseating monitoring pressure. So basically we able to monitor the thrust of the seating and unseating and be able to monitor the basically health of the valve. And if we can see the actual monitoring of the actual buildup coke inside the valve. So after we unseat the valve to required pressure, we tell our servo motor here to rotate the valve to a proper drum, and then rotate it. And whenever it rotates to the proper drum, we send the signal it's the correct drum, and then we basically reseat the valve, which again just takes the hydraulic fluid from one side of the cylinder into the other, monitoring the pressure to make sure we properly seat the valve, and that's it. So just to kind of go over what I was just saying, there is a mechanical overview, hydraulic power source, which required with a hydraulic cylinder and position feedback, and accumulator with a pressure transmitter required to seat and unseat the valve. Additionally, there is a hydraulic manual override, which you basically can use in case of emergencies of no power available. You can basically use it to unseat and seat the valve. Rotary overview probably just gives you a view here, which gives you the basically gear operator and the hand wheel, which is responsible 360-degree operation. And here you go, you have the rotary encoder position feedback with a servo motor, which have geared coupled to the bull gear. And here you have the clutchable rotary hand wheel and adjustable visual drum position feedback. So due to the fact that we utilize this type of technology, and it's very general, servo motors are very extremely reliable automation devices, I would say, as they use all over the automation, but have not been used in a delayed coker unit. We're able to achieve a very awesome technical specifications, which basically we can take power supply anything from 24 VDC to 480 VAC. We can take any input signals, basically create different type of power loss failures. Basically, we can fail last, then you go to the position, you can go to a different drum. Basically, everything is encoded and can be set within the actuator, which is awesome. Additionally, the control enclosure and actuator itself rated to vast variety of temperature, basically all across the globe, to cover all across the globe. Then you still have a position feedback, which monitors the gap of seating and unseating. Additionally, you can get the limit switches, which are going to additionally provide you a additional kind of feedback back to the DCS or SAS if you require. And there is, of course, hazardous area rating classification to cover all the world. So just to give you an overview of actual how the HMI looks like and definition of functionality. So every single actuator comes with an HMI screen, which will have this type of menu on the front of it. So each actuator will operate in auto mode, manual mode, or hand wheel mode. There is also login, which is used to put the password in and be able to use the setup button. Additionally, there is I/O input-output monitoring, which is capable of providing, and there is basically a setup button. So just to show you, whenever 99% of the time actually will be in auto mode, and this is what you're gonna see. Basically, you will have the drums at each point in time. Then you will see a reflection of actual run permissives and actual signals be sent to the actuator. If we don't receive the signal, it will be turned red. If we receive the signal, it's going to turn green. Additionally, we see seating and unseating forces at actuator at each point, and also we will see the seating and unseating percentage, and additionally the actual inches. Of course, we also will have the move time to unseat and seat the valve. That's additional kind of capability. Additionally, you can put it in manual mode from HMI and operate it directly from HMI. And additionally, we now provide push buttons and LED lights just to kind of reflect it separately from HMI as an additional reliability feature. But this is what you can use just to unseat and seat the valve, and also rotate it to one way or the other within a drum. So also, due to the fact that we use a servo motor, we are able to change the speed of operation of this unit at any point in time. Basically, if you would like the rotation to be faster, slower, have the intermediate stop between each drum and stuff. So this is all can be set within our general setup, and it's extremely simple. Basically, during the installation, you just plug in the values, tell what to go and what the actuator needs to do, and it will do that. This is basically just a setup screen just to show you how simple and easy it is to set up. You click the next button, and it will basically drive you through with the actual tutorials of what to do and how to set up the actuator. So this is rotary, speeds and operation, linear calibration of seating in and seating. And here you have actual I/O, which gives you raw values of each and transmitter within the system, and at every single point, and give you an actual feedback and lights which represent you what is working, what is not plugged in, what is not, if there is some kind of failure within the pressure transducer or anything, you're able to access it instantly. So what type of features and benefits we get with this actuator? So first of all, we eliminated the whole hydraulic power control unit, and it's self-contained. It's minimal footprint. It weighs barely, it doesn't weigh that much of weight or anything. It just can be put directly on the valve, connected with just a few cables with a control enclosure. We still utilize the hydraulics to seat and unseat the valve, which basically is the main key, as sometimes the seating and seating a valve is actually really tough. It's a really tough application and would basically require a lot of force to seat or unseat it. But at the same time, we can monitor the seating and unseating value, which we can monitor the actual health of the valve seating and unseating. Additionally, we can see the gap of this seating and unseating of the same valve, and we can monitor if there is any actual coke is getting built up inside that seat, and we can prevent that and send you that alarm, hey, your seat is being built up with coke, you need to break that valve apart and clean it up before it actually fails or completely gets stuck. So utilization of hydraulic have a very crucial benefit over electric whenever it gets over torqued or cannot unseat the valve due to the valve stiction, or it's actually getting misaligned and can basically seat getting slightly jammed as due to the fact of the alignment of the stem within. Additionally, you still get all the high position resolution feedback, HMI setup calibration and monitoring, advanced diagnostic setup. All of these features and values can be transferred via Modbus or Ethernet IP or any other smart communicating protocol, which can be basically programmed within our action. So additionally, this is all in one package. So MEA does everything for you. Basically, you just come, install it, and forget about it. You just have to drive us the signal, give us the permissive, tell us what you want the actuator to feed back to DCS and SAS, and all of this package is basically installed within this one unit. And you don't need any PLCs. You don't need any additional functionality. You don't need to convert the actuation of this one switch valve into the whole engineering project, as we will do it all for you. And this is actual standard package, which is additional benefit. This is the same, this hydraulic power source, and a lot of these components are basically used in the same application that we use all across the industry. So these spare parts and availability of these spare parts is common, and if you have any trouble or anything, we are always there to provide it to you in a minimal time. So additionally, of course, and final, probably with all the ability to control, monitor, diagnose, yes, additional feature actually, just forgot to add that there is due to the fact that we use the servo motor for the rotation, also we able to monitor the torque output to this servo motor. So we actually graph you the servo motor torque output, and it gives you ability to understand if there is any type of friction within the valve during the rotational motion. So it's not only seating and unseating, but also the actual rotational torque output, and gives you basically also additional value to understand how's the valve doing. Is it bad? Is it good? In a good condition? Do we need to service it? And besides all of that, of course, you get, in case of power failure or any, you get the manual hand wheel override. You have seating and unseating bolts. Additionally, you have a seating and unseating hand pump, and additionally, you have the rotary gear hand wheel override you can use to rotate the valve. So in general, this application have been this actually been developed about 3 years ago, but we understood that it's and it currently used on a Coker switch valves. However, this the same application, the same actuator can really help out a lot of other application, especially in the Wedgeplug style Coker switch valve and isolation valves. These can be used to operate these Coker isolation valves to be able to reliably to seat and unseat and the valve, and keep this functionality of this valve as reliable as possible, and give you the insight to the what's going on with the valve and why it's not operating. It's actually going to tell you what's happening. So basically, general applications for these actuators would be, of course, Coker switch valve, Coker drum isolation, Coker drain valve, furnace feed isolation valve, overhead Coker drum isolation. So any type of isolation valves which require Wedgeplug isolation actuator system would fit really well for this application. So currently, we have this actuator working in our partner for about 2 years now, and it's proven to work well and gives a good understanding to customer, gives them the full monitoring of the valve and ability to safely and really reliably operate their delayed coker unit. General, thank you so much for your time, and I hope you will have a lot of questions which I'll be able to answer to you a little bit after this presentation. Thank you again. Goodbye.